Welcome back to class. For this simulation, we are looking at resistors in series. My name is Amara. I am the physics teacher on Akadastore. Um, when you connect elements in series, it's connected one after the other. Now, the formula that was given to us for resistors that are connected in series, if I'm looking for the effective resistance here, what is the total resistance that this circuit has? The formula is simply the summation of the individual resistors or resistance in the resistors. So it means this is supposed to actually be 30. If I go by that, 10 plus 10 plus 10, 30. So just for the sake of make it easy, I've set this voltage to be at 30. And then I've also removed any form of internal resistance of the other elements. So let's just see what happened. We measure the current in this load. The current in this load is 1 ampere. So if we go by this, V equals IR. If indeed is true that the total resistance is 30, 10 plus 10 plus 10 because it's connected in series, then it means that 30 equals I times 30. Then if you it means that I equals 30 over 31 ampere. That's what you're seeing here. Okay. So the when elements are connected in series, the summation, simply the summation of the resistance tells you the total resistance that is being offered in that circuit. All right, it tells you the total resistance. Now, there are implications of series connection. That is also in your note. But let me just demonstrate something to you so you see. Now, I've disconnected one resistor. And you can see that even though my switch is closed, automatically there's no more flow because it's connected in series. Now, it's really pretty simple because this is the power source. The voltage is the one pushing out the electrons. So by the time the electrons came to this point, there was a break in the circuit, and so it couldn't continue. So automatically the circuit was open. So that's one of the implications of series connection. There are times that this is used for reason of control in a circuit. So you will use a series connection. There are other times it's not, it will not be used. Okay, so this is what a series connection looks like. Then I'm also going to, I mentioned internal resistance to you in your notes down the line. So let me just quickly show you that. Now, internal resistance is defined as the resistance that an element in the circuit offers. Internal resistance is the resistance to current flow within the battery itself. So this is outside of these other resistors that you're seeing. This battery it's possible it can come with its own internal resistance. Okay, so just for the sake of demonstration, let me put, okay, this is if I reverse the flow, oh, I thought I could easily show it to you here. This is voltage. Let me see. Okay, let me use the bulb. Initially, I set the resistor, internal resistor at 0.0 ohm, like you can see. Now let me increase the resistance of this bulb, the internal resistance of this bulb. Watch what happens to the region in the current. You see? You see? And you can also see the movement of the electrons that is dropping with every increase in the intake. So it means if you're talking about now the total resistance in this circuit, it means 10 plus 10 plus 10, and then you're going to factor in this 82 ohm of which is the internal resistance of the light bulb. Okay, so that's what internal resistance looks like. This was the external resistance, the resistors that are connected in the circuit. Depending on the load you connect or the battery, those ones too can also have their own inherent internal resistance. But we'll talk about that more as we get along. I just wanted to just quickly show you that. Okay, then okay, let me remove this. All right. Now let me also show you this. If I increase the voltage, if I reduce the resistance, or yeah, if I reduce the resistance here, also watch it. I'm making this 5. If I make this, if I reduce it, you see, for each of the, you see the the reading on the ammeter, and you can see that the electrons, there's an increase in their movement because more power, more energy is being pumped into the circuits, and so more, there's the current in the load has increased. Okay, now let me also manipulate this for you, the volts, the battery. If I increase it, you can see the movement, you can see the reading on the ammeter. And if I reduce it, you can also see that. So that's basically that. So I've demonstrated the internal resistance in a circuit for you. Okay. I also want to show you one last thing. In a series connection, the voltage across each of the resistors are not the same. Okay. The current is the same, but the voltage, they are not the same. So let me just demonstrate that for you. The total voltage in this circuit is 43 volts. So I'm going to measure the voltage across each of the resistors. Now, the resistors have also varied the figure. Okay, let me vary this one too. So it's not, let me make it, let me make it 15. Okay, so I'm going to measure the voltage across each of them. This one is saying across the voltage across the 5 ohm resistor is 7.17. Across the this, sorry, 14.33, and then across this is 21.5. Now the total sum of each of the voltage V1, V2, V3 will still end up giving you 43. But when it comes here, it splits according to the value of the resistor. So, but if you take it across from here, it will give you, see, 43. Okay, I wanted to just demonstrate that. Now for the ammeter, the the reading is the same current is flowing through all the resistors. So if I put this here, this is 1.43. If I put it here, see, 1.43, and if I put it here, 1.43. So that's something to note, that in a series connection, the voltage across the resistors are different, while the current passing through them are the same. Okay, good.